Sabha. I am from Cloudenablers. I am the CTO at Cloudenablers. I have Satya with me. Satya is the solutions architect with Cloudenablers.
Hi, everyone.
Good afternoon, everyone. So it's going to be immediately after lunch. It's going to be a little tough to come back to your listening mode. So Cloudenablers is basically a cloud orchestration company. We specialize in orchestration around OpenStack, OpenDaylight, and AWS. We have our own framework called Core Stack for orchestration across this multi-cloud and OpenDaylight. So today we are going to talk about schedule-based orchestration of campus network. So our agenda today is going to be touching upon what is the traditional campus network, what is the next generation expectations of campus network, how a network orchestrator along with OpenDaylight can solve some of the problems and meet the expectations of the next generation campus network. And with that, actually, we are going to touch upon the technology aspect of how we have achieved the schedule-based orchestration using OpenDaylight. With that, we will be covering a technical architecture of OpenDaylight. We will be touching upon the MDSAL, and we will be touching upon the template engine. The template engine is basically how it manages the orchestration of network elements in a repeatable fashion, what we are doing, how our task flow mechanism works. We will be covering as part of our template engine. And we will be talking about the advantages of using template-based orchestration rather than going with the API-based orchestration. And then actually we will be talking about the policies and schedules on how we can orchestrate the network in a campus environment. So these are all the agenda that we are going to cover today. The next generation campus network. So when we say campus network, we are actually taking a use case of ITES or IT environment, where actually the compute elements and devices are connected to the various network components. So traditionally, the networks are static. Basically, these are all pre-configured, and the VLANs are configured, the QoS are pre-configured, and these are all operation intensive. If we have to make changes to these network elements, we have to go and touch each device and make the changes, or we use some network management system to manage it, and all of them are vendor specific. That is how the typical IT and ITES network elements are today. With OpenDaylight and with the network orchestrator, there are multiple problems that can be solved for the next generation campus network. How it basically, the OpenDaylight brings in the concept of programmable network interface. So we can actually program through the OpenDaylight Northbound APIs, and OpenDaylight abstracts all the southbound connection to all the network devices. So it exposes the API, and then we have a layer, we have an app that is called the network orchestrator, which talks to the OpenDaylight Northbound APIs in templatizing some of the actions that need to be performed in the OpenDaylight, or some of the actions that need to be done in the network devices. So it brings in the concept of automation, and it brings in the concept of automation and policy-driven automation through template-based mechanism. And with that, actually, I will hand it over to Satya. He will be covering the network orchestrator, what are all the components involved in the network orchestrator, how we all solve the network orchestrations through our network orchestrator.
Thanks, Sabha. Thanks for setting the context. Let me go back to the previous slide. So if we see here, with SDN, right, introduction of SDN, definitely SDN, as Sabha said, it has provided a lot of, programmable interfaces, various functions to make network dynamic and at times reactive and at times proactive. Now, what is actually missing in any business on any enterprise, right? When they actually, network is just one part of the infrastructure. It actually, in order to have the optimal usage of any infrastructure, right? It is also, consist of the common infrastructure where basically the business application or various business services that has to be consumed by the end users. Now that is where we thought, you know, a orchestrator is very much required, which can leverage the capabilities of, you know, any SDN application, in this case, be it the ODL, and how we can provide a better optimal, you know, network workspace sharing and in different campus networks, be it actually in education space or in any enterprise space. So that is where, you know, the role of network orchestrator comes in. Actually, it will be wrong, or it is actually not only the network orchestrator, because it is not only you know, connecting to ODL or various network components, but actually it does something more than that. But because of this context, in this context, we will still continue to name it as, you know, the network orchestrator. So how does it, I mean, as Sabha said, right, it can be, let's say, policy. Now we have, you know, OpenFlow provides various means of, you know, at the end of the day, what is happening in the network is on the consumption side, it can be any kind of, it has to be a data communication. Packets has to be, you know, transferred from one place to other. Second is the monitoring management aspect. Third is the security, governance, policy, defining the ACL aspects, right? So in those contexts, so starting from, you know, onboarding a switch, making it OpenFlow enabled, okay, making, you know, the port profile configuration, or setting up some policy. Some policy, it can be people-based, it can be, you know, IP-based, it can be, you know, packet or transaction-based, what kind of packet is transmitted in the network, and scheduling. Certain things we know, I mean, business, non-business hours, based on certain events that, you know, happens or occurs in the network, and accordingly, you know, we have to change schedules, execute something dynamically, give access to someone, block access for someone. So all these things are actually the basic premises of coming up with a tool or framework, which is basically the network orchestrator. This is basically to leverage, you know, the features and functionalities that is available in any SDN, and ensure that it actually gives, you know, better business value to any organization. So in that thing, so we at Cloudenablers have one orchestration framework, that is core stack. So converged orchestration engine. Stack actually stands for the entire IT stack. It is not only network virtualization, any cloud, any virtualization, and any configuration tools. So if we take a typical workspace or, you know, campus network kind of thing, right? It starts with a switch coming to the network, basically a basic switch provisioning, enabling OpenFlow, then creating projects. There can be various groups or various projects or various teams, setting up, you know, adding users, removing users, the MAC address, you know, and again, configuring the access control list for all the users. Then, because they are going to share the common infrastructure, which is mainly the computing infrastructure. If we take one, you know, BPO or ITES space, because of the number of people and space constraint, maybe there might be 2-3 schedules in a day, and each and every project group might have different requirements when it comes to, you know, consuming the same IT network. And third, as we said, you know, it is all about policy and governance. So how do we ensure that the security is enforced, the policy is enforced? So that basically core stack, you know, connects all these dots and provide that life cycle that requires for any enterprises to realize the next generation campus network that Sabha talked about by leveraging SDN capabilities, right? So in the next slide, we'll we'll just you know, pass through, because OpenDaylight, I think this forum is mainly expert in when it comes to OpenDaylight and its overview. But there are two key points here. OpenDaylight is basically, when it comes to southbound OpenDaylight, ODL takes care of all the functions, and it exposes basically be it topology, discovery, or any statistics, notification, all such device manager or inventory. So it does all the southbound functionalities, where any orchestrator comes in, is getting all these features and realizing the northbound interface. So in a typical SDN enabled network. And in order to realize that, definitely the MDSAL is the approach where it helps because of the model driven. So any function that has to be exposed or configured across a network, that can be model driven, and of course the Yang structure makes it even more flexible and easy to orchestrate or model any such network functions. So now what exactly we are doing, that is the key thing here, right? So where we come in is basically, we have a template engine. Now core stack template engine connects with OpenDaylight. And if you see the main constituent of this template engine, it actually has one workflow. So workflow, a template, right? We'll see in the next slide. It consists of what should be, if I am going to perform any action, what are the input parameters, output parameters? What if this execution fails, this action fails? What we have to do? What if it succeeds? What is the next step? Should I stop? Should I do? I think in the last thing we talked about, batch flow, right? Something similar to that. So if we have to continue configuring something, or we have to continue, or we should stop the execution. So in this right-hand side, what you see in this architecture is basic workflow queue. So anything is a template is basically realization of any enterprises or organizations' business processes in terms of a workflow. Now that workflow might consist of a single template or multiple templates. So they come, anytime we trigger any action from core stack, that comes to this workflow queue. And from there is actually the template execution engine. If it is an on-demand execution of any template or actions, that goes to the scheduler. If it is, that directly comes to the task queue. If it is, scheduled, then it goes to the scheduler, and at the specific time interval, it gets executed. So in the task queue, again the task in a template consists of, again, collection of tasks. It can be more or one task that can be defined in a template. So the task, again, we can tell it whether this task has to be executed sequentially or parallelly. So that is where the task executor comes in. So, and task executor is basically the key thing which actually talks to the ODL plugin, that what we have, ODL connector. And it talks to the, API is exposed, and it does perform all these functions. Now, once the task is executed, based on the output, it again goes back and checks in the workflow queue, do I have to do something else? If not, then the output is given to the user or in the dashboard based on what is configured. If there has to be again a subsequent task that has to be executed or performed, it again goes through the same iterative cycle. So the next slide, let us look at a typical template which is used to configure, create a flow between two hosts. So when we talk about creating a flow between two hosts, what we need basically is definitely the source and destination host. What we need is the DHCP marking, what is based on what kind of data that is being transferred. And of course, that's it, right? So what if you, I am not sure if you are able to see the template content. So the first part is basically the basic metadata about the template, be it author, version, and things like that. What is the objective of this template? in terms of name and description. Second part is where we have to define the input parameters. So while we are defining this input parameter, right, here again, the application of template comes. So input parameters, it is not going to be the string. If we want to specify any allowed values, we want to specify any constraint, let's say in terms of IP or MAC address or any such things. And if at all it has to be also, we can specify something, pull out the list of MAC addresses from the switch. So it can be also another input which goes and talks to the switch dynamically and gets the list of MAC addresses that are available discovered in the switch. So then again we can also define the output structure, in what output format we need it, because the way we want to make it readable. So if you see in this, there is one task, and within that task, there is the action. So this action is, ODL QoS config. Now this is how it is abstracted. So all the programming, be it Java, Python, or any API calls, now that is something which is abstracted from the user. So anybody can come and execute the template. Now all they need to know is what is that is required to execute the template, what are the inputs I should give. That is what is required. But how that template is getting executed, what APIs are getting called, tomorrow we again upgrade the APIs or we make changes to the APIs. So the network administrator or any operations person, he need not to worry about all those things. So that is shielded by this template. All they need is at the end of the variables in terms of what input and what output they are getting, right? So that is where main thing template comes. Now in this task, each task, as I said, we can have multiple actions. So if it is, let's say, create a project or enable open flow switch, it is this thing, or there are multiple actions to be performed. So all of this can be specified in the task section in this template.
Yep. To add one more point here, there will be a lot of standard operating procedures for onboarding a switch. There may be onboarding operations commands for configuring a ODL or a switch. So what template provides is, it provides a YAML structure, and we can have a template for each standard operating procedure. Say you want to configure a VLAN, there can be a template for configuring a VLAN. There can be a template for onboarding a new switch and configuring OpenFlow for at a global level and port level and adding it to the OpenDaylight controller. There can be one template actually which takes care of all this action. The template is basically what it does is it generates a graph and executes the non-dependent task parallelly. Say for example, if you have to onboard 10 switches to your OpenDaylight controller, when you execute this template, all this 10 tasks gets executed simultaneously, and all these 10 switches get onboarded to the ODL at the same time. If you have to go and manually do it, we have to go log into the switch, configure, enable OpenFlow on a command line for each and every switch we need to do. So using a template and applying this template across this switch actually helps us onboard all these switches into the OpenDaylight at the same time. This is one use case. Once you onboard the switch to the OpenDaylight controller, there may be multiple actions that we may want to do it in the switch. There are cases where we have to apply control plane activity through OpenDaylight. There may be cases where we need to apply certain things through the SNMP directly into the switch. So we can have templates which takes care of both. So there are cases where we actually push certain configuration through SNMP directly to the switch, and there are certain control level actions that we can do it directly through OpenDaylight API through the templates. So that is the advantage that the template provides in automating the various actions required for network operations.
Thank you, Sabha. Now, when we go to the benefits of the template, right, obviously, as we said, it abstracts the complexity involved in connecting or performing any network action, whether it is directly on the switch or going through, the OpenDaylight this thing. So today it might be the plain vanilla ODL. Tomorrow It might be, another OEM's specific version of ODL, let's say Brocade, SDN controller. So the implementation might vary, or the way they have to operate might vary. So they need not to worry about all such intricacies that is involved in calling each and every action, right? So first thing, it shields the implementation details, which maybe a network administrator need not to know and need not to worry about. The second is, the most important thing is reusability and repeatability. So what it gives is the same template. It is a skeleton or a blueprint. Now only based on various needs, the variables in terms of input that varies. So we can execute it multiple times, parallelly, sequentially. So as per our need, we can schedule it. We can do a on-demand execution as well. And mostly what is not available here is we can group some of the templates, create a blueprint, and execute it. So, so it allows parallel and, execution of non-dependent tasks. And it also, as I said, helps in, if at all there is a dependency on the previous task, on success or on failure, what needs to be done. Should I go ahead with the next task, or I should roll back, or I should stop the execution then and there. So all those, the workflows related to any business or organization can be specified through templates. And for the users, as in the network administrators or any other operations administrator, it is a set of declarative statements. So it is easy to use, easy to understand for them at the end of the day, because they are going to consume all these templates. So it is easy for them from consumption perspective. It is easy to understand, easy to operate, and of course easy to execute. Right. So template was one aspect. Now anything, be it policies, schedules, all this hover around mainly the templates. So from core stack as a network orchestrator, right, we can have predefined or recurring schedules. There can be schedules on demand, as in based on some events. Let's say I got some abnormality in the network through some monitoring or statistics data, and we have to accordingly create a schedule, do something after 5 minutes, or do something after 1 hour, or block some port temporarily for 1 hour or whatever time, right, that we specify. So there this schedule plays a vital role. Similarly, when it is policies can be defined. Again, dynamic policies. There can be policies which are event aware. It can be based on the performance trend. It can be based on the application behaviors. So that is where I was trying to tell, it is not only the network orchestrator, right? So then it becomes an application orchestrator, because it also understands the application behavior, and accordingly it does something. If it has to fine tune at the network level, it comes and it does, the orchestrator does that. So and if at all, again, this takes into the next step of remediation. So when we know, we can understand, the platform can understand the events or any thing, abnormality associated with the system. It also ensures that if at all there are some remedial actions in terms of templates that is available, that is configured, then it goes and execute it. It need not to wait for someone to manually come and intervene or act on it. So it is near real time, right? And topology discovery. So again, core stack has the mechanism. It connects with ODL Northbound APIs, and it gives the inventory of the host, the switches, flows, links, the number of projects, number of users. When we add any new compute infrastructure, it automatically gets added to the inventory. Onboarding a switch, whether it has to be a single switch or it should be added to a switch group, if there are predefined profiles or flows that has to be configured. So it takes care of the various things when it comes to onboarding of infrastructure, not only the network, but other aspects of infrastructure. People coming in, moving in from one project to other, all those such operational things, right? It actually takes care of all of that. Now, with that, we came to an end of the presentation. What we are going to, you want to spend some time?
We'll do a
Okay, we will show you the solution. Let us take 5 minutes and see the solution. You can.
Visible?
Yeah.
Yeah. So yeah, we talked about so basically, your network orchestrator, which orchestrates the provisioning of a switch, enabling the switch and adding it to the OpenDaylight controller, and then managing a policy for a particular project in an ITES environment is what we are going to showcase in this demo. So this is a network orchestrator specific to shared workspace management, where actually a particular network workspace is shared for multiple projects, and each project actually has its own policy, and each project has its own timeline and access control definition. It has to be changed based on time. In a normal traditional way, we have to go and manually change it. Through ODL, we can automate the entire process. Based upon time, we can change the network policy for all the different network elements involved in it. So the workspace management starts with actually defining the OpenDaylight endpoint, the controller endpoint. So here actually we have integration with Brocade SDN controller. It can be any other distribution as well. So we can capture the endpoint of OpenDaylight here. And then once we capture the endpoint of OpenDaylight, we have a discovery mechanism. The discovery mechanism discovers all the different components available in the SDN controller. So when we say the different components, the whatever that we listed as part of it, host, flow, the link, the switches. So it discovers the entire the components available in SDN controller. So if it is a greenfield environment, or it can be a grayfield environment. So if the switches are not already OpenFlow enabled, we allow the user to define the switches as part of the inventory here, and ask the users to add the switches, and we provide mechanism to add or automate the enablement of SDN controller, basically for the switches. If it is already OpenFlow enabled, we discover the switches through OpenDaylight topology discovery, and then add it to our inventory system. So by the way, we will be managing all the inventory of the different switches, the host, the users, the projects in the network orchestrator, so that we can define the policy and orchestrate the policy as per the project requirement. So that is the end objective. So that can be done either through OpenDaylight or the user adding the switch and then automating the process of adding the switch to the OpenDaylight controller. So here, once the endpoint is defined, we also allow the user to define the different switches and group the switches. The switches can be all the switches on the first floor can be grouped, the second floor can be grouped, or actually it can be a different the switches, all conference room switches. So there can be different way the switches can be grouped and the policy can be defined. we can apply the policy directly to a switch, or we can apply the policy to your entire group of switches. So we provide a mechanism to define the different switches and then actually group them based on whatever requirement that the customer has, and then apply a policy against the group of switches. For each of the switches, actually we also provide mechanism to view all the different policies which are applied to those switches. So what are all the, we can have different policies applied to the switches. What are all the policy applied to each and every switch are actually listed here. And then similarly, what are the port utilization. So this is another important aspect. So currently, since I have connected it from VPN, it is not bringing the port utilization. Say, one of the important aspects is for a network administrator, he needs to know how many ports are being currently utilized, how many hosts that he can actually add. So it gives a dashboard view of how many ports in a switch are being used, how many are available for consumption. And then actually it also allows to map the switches into a group, also into a particular project. So the project can be a combination of multiple floors or multiple group of switches. So that is the next level of definition that we will be seeing here. So here is the project definition. Say in an IT or ITES environment, there may be different customer that a company, maybe organization, may be servicing to. And each and every project has its own policy, own access control. There may be a VLAN associated, a set of VLAN associated with that particular project. And there is going to be a set of policies associated with that project. So here we talked about defining the SDN controller. We talked about defining the various switches. And we talked about automating the process of adding the switches to OpenDaylight controller. And then we are talking about a definition of project. So once we define this list of projects in an organization or in a building, in a campus, so this orchestrator manages the automation of applying the policy based on a time-based mechanism to the project. That is what it does. So once we define a project, there is going to be a policy associated with the project. So what is the network access control policy that I'm going to have? What is the data VLAN that I'm going to have? What is the bandwidth that I'm going to have for that particular project? So those are all the different policies that we can set and apply those policies against a project. So when you apply a policy to a project, there are going to be set of switches which are associated with that particular project. It can be, again, a switch group or individual switches. So when you apply this policy, it can be a shift-based timing, say morning 10 o'clock to morning 6 o'clock to 2 o'clock. There is going to be first shift, and the project A is going to use this network infrastructure. So there will be a policy associated with it. So these are all the different policy definition that it can have. Timing, start timing, end timing, what are all the switches that belongs to that particular project, what are all the switch group that belongs to the project, what are all the host-based access restrictions that we need to apply to the project. So all these things can be defined as a policy, and then this policy can be scheduled. So automatically every day it can be a day-based schedule, or it can be any flexible schedule. So we can apply this policy automatically at 2 o'clock. The policy starts for this particular project, and then it ends at 10 p.m. So then actually there may be a new project which starts using the same network infrastructure, but it will have a different policy. The network configuration is all changed. In a traditional environment, actually we need to go and manually change all the switches, configuration, and everything. With OpenDaylight, with the network orchestrator, which is specific to this particular problem, can automate the entire aspect, dynamically changing the network policy for a project based on a schedule and time. And again, there are few other actually dynamic things that we also incorporated apart from the static definition here. What you show here is a static definition. Your policy is defined project, and the time is defined. So based on the time, it automatically orchestrates the different network components involved. There are cases actually where we have to go through OpenDaylight for configuring certain things. There are cases where we have to go directly to the switches because we have the switch endpoint already configured as part of the inventory. So we go and directly configure certain items to the switches through SNMP or netconf protocol. So you want to add something?
No, I was saying RESTconf.
Yeah. Okay. Any questions so far? Correct. The target resources, basically it's a compute infrastructure backed with, say for example, it is a port level policy. It can be a set of computers connected to a particular network, and then actually making this 50 ports part of a project, and then having a access control definition for within this 50 network ports. It can be a block A, block B. They belong to the same VLAN now. So after 2 p.m., there may be 3 blocks which constitute one VLAN. It can be a different VLAN, different network policy. So dynamically changing the network policy is what this particular solution solves.
Do you have also any bandwidth level controls built into
So
this?
yeah, I mean, basically the policy that actually we showcased here is configuring a VLAN, configuring a network access control, configuring a host access control, and defining a QoS for a project. And basically what you see here is a user interface for the action that can be performed. But how the action is performed is where our technology lies. These actions are performed through what we talked about as a template engine. So the template engine, basically for each and every policy, we generate a template at the back end. And then the template goes and talks to OpenDaylight Northbound API or the switches using its access control mechanism and then configures it. So what actually it provides is the flexibility to do a lot more configuration based on the requirement. It can be a event-based configuration based on the SNMP alert. It can be a bandwidth definition. It can be a bandwidth threshold definition. It can be a packet definition and then taking some action based on the packet, because the template gives us the flexibility to change the configuration dynamically.
Okay, last question, I'm not sure if you covered is, are there any components of OpenDaylight other than the plugins or netconf or OpenFlow or OVSDB, any applications that are built into OpenDaylight that you're leveraging for this feature?
Okay, so if I understand your question correctly, we are using the topology discovery of OpenDaylight and then the SNMP plugin application in OpenDaylight for configuring directly to the switches. I think those are all the 2 core components that we are utilizing, apart from the OpenFlow. Yeah.
Okay.
We have both the models. Actually, this application, the shared workspace management, can work as an independent application, and we also have the same thing integrated within the OpenDaylight application. We actually made that as an app within the OpenDaylight. In that case, actually it by default takes the OpenDaylight endpoint, by default gets the topology discovery from the OpenDaylight API, and then goes through that. So in that case, the BSC account will not be there. So we wanted to give a flexibility, because there are cases where there may be organization which transition from a traditional network to OpenDaylight based network. So that's why we wanted to keep this UI separate, to support both the models. So to answer your question, we support both the model as a standalone application or as an OpenDaylight app.
So if it is an OpenDaylight application, won't the Yang model or the Yang definition solve the template issue also? So the Yang model which we define for the model driven, right? So can't we use this the same as a template for this application also, instead of writing 2 separate, one template here and one template for the model?
Yeah, basically, YANG provides us an ability to expose a Northbound API through the model-driven controller. But actually, here this YAML-based template, what it does is actually on the configuration of this aspect. So, once you have the actions exposed through the Northbound API, there may be various actions that you may want to perform on the OpenDaylight or onto the directly switches. So that's why actually we need to have a template engine outside of that forms the YAML-based structure to do all these actions. Yes.
Can this be version controlled?
Yes, it can be version controlled.
As in, can you have multiple versions living, either multiple versions being active?
As in, let's take an example, this QoS config, right, is an action. Maybe in one ODL version, it requires 4 input parameters, and in another ODL, maybe it requires 5 or maybe 3 or something like that.
Correct.
So is that question is something related to that?
Correct,
Yes,
correct.
it can be version control.
Okay.
Yeah.
Yeah, so my question is, if I look at this, this is more what similar to like we have a chef has that cookbook and recipe.
Yeah.
Okay, so does this support like because whatever the template we are defining here, the same thing could be defined in that cookbook and recipe, and that can be integrated using the workstation. So how it is different from that approach, or does this orchestrator integrate with chef also?
Absolutely, I think that's a good question. Actually, there are actually very thin line of difference between a configuration management app and the orchestration application. So Chef actually falls under the criteria of configuration management tool. So it provides a Ruby-based mechanism to manage the configuration of an application in a VM or a server to some extent to a network device. But it is not a pure play configuration management tool for network devices. So here, as an orchestrator, what it does is basically, it talks to the APIs and it performs a task against all these APIs. So that is the difference. So basically, that manages the configuration within the system. But here, actually, we can construct the various actions using the API and then perform actions against it. And then actually, it also not just actually pushing a configuration to your device, it also based on certain the data that we get, and then how do we apply certain actions based on the data that we receive. It's a bidirectional basically.
And Chef is mostly stateless, but this is something state aware. I mean, if you see the project, right, what are the users available in that project, what are the switches in that switch group, etc., right? These are certain things not available anyway. This is stored here, right? So certain information or the output of the previous state, or so that is where it becomes handy. I mean, definitely.
Yeah, so that's most that is what your application is adding value on top of that, correct? Yeah. But the technology is like you have like through ODL anyway you are going to use SNMP plugin to configure those switches, correct? Or as like in template, if you have enabled like this VLAN,
right.
You want to create this VLAN, or suppose you want to enable OpenFlow on that. So all those configuration you would be first using that SNMP plugin of ODL, correct?
Absolutely. I mean, actually, see, when we say CoStack as a converged orchestration engine, we utilize some capabilities of Chef and Ansible. So basically, Chef is powerful in terms of configuration management. So when we have to orchestrate multiple tasks, you need much more on top of actually Chef. That is what actually this application does.
Thank you.
Any questions?
Okay. Yeah. Thank you. Thanks.
Thanks for your time.